Right, well, good evening, everybody. Thank you for coming out. I'm here tonight primarily to present the latest member of our lineup of RISC OS computers, the ArmX6. I will digress at certain points onto some of the software bits and pieces as well, but the primary reason for being here is to talk about the ArmX6 and how we developed a completely new port of the RISC OS operating system, pretty much from the ground up for the new hardware. Those of you who are familiar with our previous Harmony range of computers will know that we started life with a sort of pre-existing port to some degree. The original Harmony was based on the Beagle board, and the ArmX was based on the Panda board, albeit modified in each case, and we had custom versions of the operating systems developed, etc., etc., etc. But the groundwork was done by third parties who were eager to get those boards working. What's special about the ArmX6 is that we actually sat down and looked at all the areas where the previous hardware didn't meet what we were wanting from a next generation RISC OS computer, and looked for a solution to each problem. And the ArmX6 is the culmination of that. It all started back in September 2013, so almost 2 years ago. And that was almost a year after we'd released around a year after the release of the ArmX. So typically we wait a year after doing a machine to start thinking about what we're doing for the next one, because the first year of a machine is typically spent with quite rapid updates as new features and functions come online. And then the second year of a machine's lifespan is typically more of a maturity phase, where anything that was show-stopping is already dealt with, and anything that was not quite right is polished, and you have a much more stable finished state, if you like. So around a year after we'd done the ArmX, we were looking for what might follow on. I'd actually had thoughts on this going back as far as the original Harmony, because even then it was very obvious that things like the disk performance were a serious hampering factor on the hardware. Whilst we were seeing quite fast processors, the rest of the system was lagging behind the speed of the actual processor. So you could do a test that involved very fast number crunching, and yes, artworks would fly. But the moment you tried to save your artworks file, if it was complex, you'd be sitting there with an hourglass while it saved your file. So right back then we were looking for options that might have serial ATA, which is the technology through which modern hard disks and solid-state disks are connected to Windows machines. And therefore we wanted that for a pure ARM board. There were some interesting designs. In fact, I first came across the it was ArmX5 back then, architecture during that Harmony era, as a possibility. It was the ArmX5 was very much like a Beagle board, but on steroids. It had a similar clock speed, but just lots of extras that made it quite an exciting part for the time. But we decided at the time that really the Panda board jumped ahead of what the ArmX5 did, but it was lodged in my head that the Freescale chips were ones that we were well worth looking into, shall we say. So come September 2013, a group of us who were half of us were involved in the Harmony and ArmX project, and some of the other people involved were people coming to us who had specific requirements for new ARM hardware, particularly one commercial customer who runs RISC OS machines, typically A7000s and some ArmXs, as network servers. And they were looking for replacements for aging hardware that was, well, in the case of the A7000, chronically slow and old, and in the case of the ArmX, quite nice hardware for what they were doing, but becoming very unreliable So they were looking for a next generation platform. We also were very fortunate to have in attendance John Ballance, who some of you may know as one half of Castle, who produced the Ionics. John was interested in getting his teeth into something new, and at the same time, if that something new happened to meld with what we needed and what commercial customers needed, and so on and so forth, then it would be a perfect storm for the development of a new version of RISC OS. So we actually looked at a variety during that meeting of different RISC OS designs. I have to say the ArmX6 was always, I think, my favourite, but we did look at some of the Chinese designs. There are possibilities from companies like Rock Chip and the All-Winner chips from China. But of course, what we found with those was whilst the actual hardware was quite fully featured, unless you spoke fluent Chinese and could read Chinese data sheets, if there were any data sheets, you were basically sunk. So they tend to be non-starters. We looked at what Texas Instruments, who were behind the OMAP family, which was the Beagle and the Panda, see what they were doing. And we looked at various other different ARM designs, and each one had its pros and cons, but what we were looking for was a sort of magic set of features. So we wanted compatibility with what went before. That was quite strongly important. We didn't want everybody to have to go out and recompile and rebuild all the software yet again. We wanted serial ATA, obviously. We wanted plenty of RAM of a decent speed. Gigabit Ethernet that wasn't over USB, which is still very much a problem. Beagleboard, Pandaboard, Pi, and pretty much everything else. They love to put. They'll even try and put Gigabit Ethernet for USB, which seems complete bonkers. So we wanted a hardware Gigabit Ethernet implementation. Obviously, HDMI video output to a decent high resolution display that was known to be good at the high resolutions, and also we wanted a good shelf life. One of the problems that we saw with the ArmX and the Panda board was that we went through sort of 6 months, not 6 months, but certainly 3 months periods where we couldn't get supply of the boards and parts. And if you can't guarantee availability, it creates all sorts of problems, not just from delivering, selling stuff, but also what happens if a customer's machine goes wrong and you're out of stock of the motherboards. The customer's potentially left in a situation where they haven't got a computer for 3 months while you wait for new stock to come in. So, and that's assuming that you actually have the part available for a length of time beyond. What happens when your board goes wrong in 2 years' time? You're out of warranty, but your machine's still basically good. You don't want to buy another computer from scratch. We needed something that was going to stick around. And basically the ArmX6 ticked all of those boxes. The CPU architecture matches, in fundamental terms, what we've seen in the Panda board, albeit it sort of doubled up again, as it were. So we knew the software that worked on Panda board would work straight away on ArmX6. We had the SATA port for drive connectivity. We had HDMI video that we could see was good up to, well, the limits of HDMI basically. And we had the hardware Gigabit Ethernet and so on and so forth. So at the meeting it was decided that the ArmX6 was the way to go, and we looked at a few development boards to see what our options were and settled upon one. And shortly after the meeting, a selection of boards was sent to us, and then we distributed them round to the different people who were involved in the consortium. Very keen to mention that this was very much a group project, so rather than sort of thinking, oh, it was Arcom doing it on their own. Well, yes, we were the driving force there, but each person who was in the consortium was delivering different parts of the project. So we had John Balance there doing programming. We had our commercial partner who was setting out a wish list of what they wanted. And we had a couple of other partners who were also contributing in their own way with either designs or facilitating things. So it was very much a group effort within the community, and that's been very much at the heart of the design, that we've tried to involve as many people as possible while we've developed it, so that it can be properly tested and meet with the requirements of a goodly number of folks. So at each stage of the development, as I talk you through the development, the circle of people involved got larger and larger, because we thought that was very much the way to ensure that we ended up with a high quality product. Although we didn't say as much, the other thing that was very much in the back of our mind, especially with John Balance's involvement, was that effectively what we wanted to do is deliver the mythical ArmX6 that Castle had never been able to do. And I know John, one of the first things he said once he managed to get the hardware up and running was that this was very much the sort of feature set he would have loved to be able to offer for an ArmX6 had it been available when they were looking at it. So that was very much the project goal in terms of a desktop machine, was to deliver something that in each area of the Ionics we could say that yes, we are sort of that much further on compared to what we had before. Whereas with Beagle and Panda, there were areas where the Ionics could outperform them. For example, the Ionics had gigabit Ethernet, and it was actually an Intel Ethernet chip, which are always, you know, if you buy a PC, you want, if you get a high-end PC motherboard, you're looking to get an Intel network chip on it. So the Ionic shipping with Intel gigabit Ethernet was always quite a coup in terms of the Ethernet port. The IDE disk capability of an Ionics, you could typically see sort of hard disk speeds between 30 and 50 megabytes a second, which was faster than, I mean, we managed to get 20 to 25 out of a Panda board peak, but I mean, in practice, you didn't necessarily get that peak all the time. So, you know, we were quite clear that there were areas where we were still behind with the ArmX, although in terms of, you know, the CPU and memory performance of the ArmX more than made up for that. We were, you know, it was always slightly embarrassing that there were still areas where the older hardware offered potentially greater performance. So our objective was to deliver something that was going to exceed everything which went before it on all grounds. So, after the meeting was over, we went away. As I said, hardware went out to all the members of the consortium, and John began to tinker with the board and bring it up. Initially, John was the primary programmer, but again, as I said, things at each stage the project got wider and wider. So, John was responsible for the initial builds of the HAL, what we call the HAL, which is used to bring up the actual hardware. And then at a certain point, the scope grew, and people like Jeffrey Lee, Amul or Adrian, I'll call him, you know who I mean, got involved. And we basically increased the number of people at each stage. Ben Avison of Rule, for example, we contracted him to do some development around October time last year, for example. And so the project grew and grew. I actually have some of the different emails that came through, as you can sort of get some idea of how the project grew. The first one I'm pulling out, as you can see, it's entitled "It's Alive." This was 12th of November 2013. This was the first time that John actually managed to get any portion of RISC OS to boot on the hardware. At this point, when you start a port of RISC OS, you don't magically have all the sort of things appearing on the screen and everything working fantastically. What you start with is the absolute minimum set of the bits that you could possibly have in order to get anything to work, which is typically the hell that I've mentioned, plus half a dozen modules to get you to a star prompt. And you have all of that pumping out, not onto the screen, but out through the serial port. Because the serial port is one of the most dull and basic devices, you can just fire characters out of it. So what you're seeing here is a dump literally out of the serial port of the machine in November. But what's interesting is that even at that point, you can see that if you look, when my mouse is pointing, you can see the RISC OS 204 8MB Cortex A9 processor. This is the kind of stuff that you would see in the pre-desk when you turn on your RISC or any RISC OS machine. You see the memory, you see the processor. Typically it will say sort of Acorn ADFS or SCSIFS or SDFS or whatever, and then you'll have the pre-desk phase of the boot sequence kicking off. In this case we haven't got any additional storage hooked up, of course. So you can see no keyboard present, supervisor, and then you can see that by firing commands at the serial port, a sort of fake keyboard is being implemented, and you can see that it creates a RAM disk to actually store, so you can actually store some data in it. You can see it's created the 128MB RAM disk. You then list the contents of it. Then he drops into BASIC, which is one of the handful of modules that you tend to bring up very early on. And you can see he prints "I am alive," and lo and behold, RISC OS is alive on the new hardware. Of course, that's not a lot of use to most people because you don't really want to be doing your entire computing experience through a serial port. But from there, you have the building blocks of a RISC OS port. So from November through to Christmas, the big challenge was to try and get something on the screen, because we don't like serial ports, we want things onto proper screens. That was quite a major job because the video hardware in the ArmX chip was not something that already existed in any shape or form. This was a new graphics processing unit with new capabilities, full HDMI support. It may interest people to know that although you had an HDMI port on the Beagle and the Panda board, it was actually being driven as a DVI port. And although they are very similar, in terms of bringing them up, it's quite a different process. So again, completely new video hardware to be developed and brought up. In fact, whilst the hope was that that would be our Christmas present, would be sort of screenshots of RISC OS running on a monitor on the new hardware, didn't quite work out that way. And it took into January to actually get, January 2014, before we actually started to get video. And really, initially that was just literally some shapes on the screen. It wasn't RISC OS in any kind of meaningful sense. It was just, can we actually get the monitor to turn on and display some shapes? It really took through till February to actually get RISC OS coming up. And if I open message 2 now, you can see this is actually the 26th of February, but looking back on my email, I can see that you can see this says Taster 2. Taster 1 came on the 19th of February, and that was when we actually finally got something sensible on the display. So I haven't actually got this Taster 2, but John kindly sent me this copy of the video. Interesting comment, this is an Apple QuickTime/MOV file, and in a moment you'll actually see the ArmX6 quite happily playing the video. So you can see initially it just comes up with some shapes, but then you can see a RISC desktop phase at the top left there. And that's the basic set of modules that was running at the time. So you could see that that was RISC OS in a meaningful sense.
I'm just wondering that the MOV file,
yeah,
because I've got ArmX, if you try playing anything like Mod or anything like that, it runs pretty nastily, and that's running perfectly.
Yeah.
Is that hardware acceleration of any kind, or is it just the?
Not particularly. It's the faster architecture, and we have the software supplied with the ArmX6 includes video playback, but that particular video was not being hardware accelerated. It might be using the floating point elements. That's possibly.
Plays nicely.
But I thought it was quite. Well, when John sent it to me, I thought, oh, that would make a nice demonstration item, because with it not being as traditional like MPEG or something like that, it's a format that normally, if you've received that on most RISC OS kit, you just toss it over to a Windows or other machine, simply because you wouldn't even attempt to open it. But I thought, let's have a stab, and lo and behold, as you saw, it played fine. So that was February. The next phase after that was to actually bring up a desktop. Surprisingly, that didn't take a lot longer than getting something on the screen. The hard thing was to get anything at all on the screen. After that, it was just actually programming the video chip to actually recognise different screen modes. Initially, we hardwired a set of screen modes that would work into it. So initially, at 1280 by 800 was a resolution that was selected because it happened to work on the monitors that we were all. We had a little chat with everybody involved, and that was the resolution that we had. The video side of things was fun because the amount of documentation available was quite minimal, which is quite common. I mean, to get anything on these things is pretty rare. And we were able to, one of the project partners was a chap from Sweden, and he was working for a subcontractor of Freescale who designed the ArmX6 chip, and was able to open some doors, so we were able to get some documentation. And we were hoping to exploit that. You were talking about hardware acceleration. That is actually something that is being, that's a current project, if you like. Yeah. So during April, the desktop started to appear. Initially, mouse pointer was a challenge, so the first versions that I actually had with the desktop, which would have been sort of end of April 2014. Roughly a year ago. You had a RISC OS desktop, but the pointer was just a little rectangular blob, because that was how the hardware cursor was implemented on this particular video chip, that actually changing the cursor, although it was supposed to be programmable, when we actually tried to use the programmable hardware cursor, it didn't change. So the initial point with the click point was all off, so it was an interesting initial experience. But it gave us enough confidence to know that it was well worth going forwards. That was about the time that Geoffrey Lee came on board to assist with the project. Now, for those who aren't familiar, Geoffrey was the guy who did the initial BeagleBoard port that sort of kick-started this whole new generation of RISC OS ports to new hardware. So Geoffrey is something of a hero amongst the RISC OS community, and we were very pleased that he was keen to join in, and that gave the whole project a jump forward. As you can see from the first line, since Geoffrey came on board, there have been a couple of excellent steps forwards. Geoffrey assisted with the mouse pointer work and expanding the graphics, and also looked at optimizing the actual startup of the computer. So initially, when RISC OS starts up, it blanks all the memory. And blanking 2 gigabytes of RAM is not the fastest thing on the planet. So initially we were seeing sort of power on times of 30 to 45 seconds, which, it has to be said, is still probably faster than a Panda board. But with Geoffrey's assistance, we were able to drop that down. You can see here it says 16 seconds. In a minute I'm going to show you how long it actually takes and it's about half of that. But at that point, we were able to bring up the whole 2 gig of RAM at a much faster speed, and that allowed the project to move up a gear and actually start looking at things like networking and SATA, which were obviously big things that we wanted to really get our teeth into right from almost from the beginning. But you can't start working on that until you've got the guts of a workable machine. At this point, because we don't have SATA and everything else, the storage was via USB sticks, which was not a lot of fun, but at least allowed us to begin testing. The clock speeds of the processors were also kept very low for much of the development time. It was only very near the end of the project that we actually ramped up the clock speeds to full speed. The reason for this is that when you're debugging a system, you want to run everything in the most conservative manner, because you don't want any problem to be a result of anything being close to the wire in terms of the specifications. So you run everything in safe mode, to all intents and purposes, to ensure that you have maximum stability. And that way you know that if there are problems, it's going to be your code causing the problems and not something to do with the hardware. Moving on from July to August, things had progressed far enough that we had the USB storage, and things were pretty stable at this point. You can see that where my pointer is, USB mass storage is still only working at USB 1 speed, so overall system performance was very low. But we were comfortable that even with the lower system performance, the machine was stable, solid, and that was one of the big things that we wanted to ensure that the system was absolutely rock steady, because for it to go into network servers and the like, you don't want something that's going to crash on you going into a network server. It has to be absolutely rock solid. At this point, work on the SATA had already begun, but initially it was a lot of sort of poking and prodding with it. And this is the point where SATA work began in earnest. I think the networking, is this the one? Basically, during the last summer was when the networking driver was done before the SATA, because that way data could be more easily transferred onto the device and we could test that the system was communicating with the outside world. So during last summer, Ethernet came up, and then the work on the SATA began. Now the SATA was done as its own separate commercial product, because it was going to require some quite intensive work. In fact, it took probably the best part of 3, maybe a bit more, months of fairly solid work to actually get SATA developed. And that was quite an expensive portion of the project, getting that done. But that was very much a fundamental thing. We knew going in that that was going to be a big deal, that getting fast disk I/O and developing the serial ATA technology was going to be critical. And we were actually implementing a new protocol called AHCI, which is how modern serial ATA controllers communicate. No matter what chipset they use, whether it's an Intel or an AMD implementation or one on the ARM side of things, they all use AHCI, which is a DMA-based packet transmission system. And so developing the AHCI driver was absolutely critical to the project. It took from August through till October the 13th, that's my birthday, to actually get the SATA to a sensible state. As you can see, first cut of the working SATA driver. This was about 2 weeks before the where we first showed the machine at the end of October 2014. of the way the SATA driver was written, it was developed in small chunks and tested to, well, beyond bulletproof. It was absolutely critical that how you talk to the disk drive is bulletproof. You can't be making any compromises there because people's data relies on decent quality disk performance. And since this was going to be a critical feature of the new hardware, it absolutely could not be skimped on. Extensive use of something called FS Bash was used, which is well, initially an Acorn tool, but now a rule tool, that absolutely trounced disk systems beyond what RISC OS can actually do. It's quite an obscene test, really. And in fact, we actually found faults, while we were developing this, we actually found faults in FS Bash where what we could do actually exceeded what FS Bash was designed. You know, that when it had been designed, it had been designed speculatively. So we actually extended FS Bash in order to properly test the capabilities of the new hardware, and we had to run hours after hours after hours of this kind of testing to ensure that the machine was absolutely rock solid. I know I'm sounding like a broken record on the stability side of things, but that was what really took the time, was trying to make sure it was absolutely good to go. On the video side of things, it was actually about 2 days before the London show when we finally got full 1080p high definition video up and running properly. Initially, we would be good up to about 1680, 1050, something like that, and we found that above a certain level we were getting almost like a blur effect on the graphics. And about 2 days before the London show, the necessary screen setup stuff was picked up through testing on an oscilloscope and comparing the Linux bring up routines with the RISC OS bring up routines and checking signal for signal to exactly what was what. And that was finally cracked, so we were able to offer the full 1920 1080 at 60 Hertz, 16 million colour, etc. experience that had always been the project goal. And I breathed quite a sigh of relief when that occurred. And that was really the thing that convinced me we were ready to announce the machine at that point, because we had the working Ethernet, we had the working SATA, and we had the working 1080p 60 Hertz, which was the things people needed to see. We still weren't running at full speed, but even at that point, the combination of those technologies working together was so fast and fluid that I was quite happy that demonstrating this was tangibly a leap ahead. But we were still running at best at 75% of what the hardware was capable of, probably less than that, maybe 60%. One of the big tests that we were doing at that point was testing how long it took to compile a RISC OS ROM. Because that's quite a time-consuming thing. On John's Ionics, it was taking about 50 minutes to compile a full copy of RISC OS, which not a lot of fun. Trying the same thing on the Panda board was taking, well, around, I believe, about 20 minutes, maybe a fraction more than that. So it was quite good. But even at that point, we were down at below 15 minutes for the ArmX6. So it was already quite a tangible boost over what had gone before on something that was fairly compiling code is primarily computational. There's a certain amount of disk needed, but you read relatively small files and then you compile them and save them out, etc. So we were seeing a healthy saving. And so that's what we were demonstrating at London. What was very pleasing was that once I unveiled it at lunchtime in London, although we put it on display so that people could actually play around with the machine at the show, it wasn't sort of behind the curtain or anything. And people were I left it there so that people could goof around with it to their heart's content. And it ran for the entire rest of the show, from about lunchtime through to the close of the show, without any kind of crash or failure or missing a beat. And that again gave me the confidence that yes, we had produced something that was going to do what we wanted. After that, we moved from keeping things very quiet to much more open to the public. People were paying their deposits on machines, and we wanted to keep them abreast of things. We did take some criticism from some people in the community for keeping our information to people who had expressed interest or paid deposits. People were saying, why aren't you telling everybody in the community everything? And to be honest with you, I actually felt I didn't want to be spamming everybody who perhaps wasn't interested with lots of progress reports, the sort of stuff that they weren't interested in, which is why I asked people to register their interest or place deposits. You didn't have to put money down. You could just say, I'm interested. You could go on the list. And then, and I felt that was the right way, that people who expressed interest, who wanted to support the project, were the ones who should be getting the detailed information. And that way I could give quite, I'm not proposing to go through these individual messages, but you can see just from the length of the emails that were going out, these were fairly detailed progress reports, actually involving people in the design and choices that we were making. As we were going along, we kept finding problems and bugs in RISC OS itself. And that was one of the big things that was very pleasing, was that we were able to fix a lot of long-standing bugs within RISC OS itself. And at the end of the project, back in sort of February time, we were actually able to deliver a new version of the operating system for our existing ArmX6 customers, which fixed a lot of fairly serious bugs that we'd come across when developing this machine. So although we were developing for this new hardware, all of the features, things that we were developing for the new hardware, I've got to be careful, I said features, I've got to be a bit careful now. All of the core RISC OS stuff, I suppose, went immediately back into the RISC OS source tree. So that everybody could benefit. In this case, because both ArmX6 and Panda use the Cortex-A9 architecture, we discovered some fairly fundamental issues with how Rule had previously implemented Cortex-A9 that basically were broken. And we were able to get that sorted. So for example, in order to regulate the processor cache on a Cortex-A9, they have a dedicated cache controller chip. This wasn't supported at all on RISC OS. The assumption was that, like all the previous ARM processors, it was done effectively by the CPU itself, which is how Acorn had designed things way back to the ARM 610 strong ARM era. And so the cache control code was exactly the same as it was for all the other ones, which effectively meant it didn't do anything on the new Cortex-A9. In practice, this probably didn't make a lot of difference for 95 to 99% of the time. But it would mean that effectively it was like driving down the motorway with no functioning brakes. You're absolutely fine right up to the moment that you hit a traffic jam, and then crunch. And this actually fitted with, most of the time the ArmX and things were absolutely fine, but then almost at random you would just have an abort on data transfer, not a fatal one usually, just random abort on data transfer out of nowhere, completely unexpected, completely unrepeatable. You'd be able to go back and run whatever it was you'd just done, you'd run it again and it would be fine, but you would have these unexplained things. So for ArmX6 we developed the necessary cache control and spent, crikey, that was December, January period, over Christmas. Hour after hour after hour of testing that code, because there were so many little nuances to getting that working, and because the problems often didn't manifest themselves repeatedly, you just had to test and test and test. It was the only way to make sure that it was solid. At the same time, we were cranking the clock speed of the ArmX6 up, and it was this sort of, as we ran it closer to the wire, suddenly all of these little problems in RISC OS started coming out of the woodwork. We found issues to do with it was any machine that had that was Cortex, not Cortex, sorry, was ARM v7 instructions. So that's anything Beagle, Panda, Pi 2. The way RISC OS was accessing memory turned out to be non-ARM v7 compliant. Only a minor thing, but it relied upon two events. Something would be set and then something would be updated in the cache. Whereas it was supposed to be cached then set. So far it probably hadn't been a major issue, but suddenly we were starting to see it tripping up the thing. Now RISC OS properly implements that particular feature, stability went up. We found a long-running crash in the obey module, which is responsible for every time you click on a run file or anything, it goes through the obey module. It's a fundamental module. It wasn't RP7 compliant. It is now. So, ArmX6 project has been instrumental in delivering a much more solid version of RISC OS generally on all devices. And I'm very keen to stress that although we have, for commercial reasons, kept things like the SATA and the Ethernet and the actual ArmX6 held as private for the project because people's hard-earned money was gone into development, every other part of the ArmX6 port has gone straight back to run far faster than any of the other ports that have occurred, in fact. So, I mean, we actually keep our tree mirrored daily with the rule tree. So as we fix things, rules code gets fixed. So the forthcoming 5.22 rule builds all benefit from a large chunk of ArmX6 fixes, optimizations and improvements. So this is very much a project that is having direct benefit for everybody else. And as I say, all of our ArmX customers have had OS Update 8, which has all of the features that I've just talked about patched back into the thing. And immediately customers have said, yeah, we're actually seeing a more stable computer as a result of all those funny little, can't quite put my finger on it gremlins that were, we'd have people say, well, if I use my computer for 2 or 3 days, then I might get a crash from Hermes or something, which is rock solid, not, all these little weird gremlins disappeared. So it has been a wonderful project for actually stabilising RISC OS as a whole. And as all this came together, as I say, we increased the clock speed, brought everything up to full speed, enabled all the caching. We saw, again, a jump in performance. And suddenly that sort of 14-15 minutes that I was saying for the RISC OS compile time was down to 9 minutes. And in the end, I think it's ended up at about 8 3/4. Pretty much twice the speed of the Panda board, 5 times plus the speed of an Ionics. I don't have the times for a bigger board. I mean, a Raspberry Pi is somewhere in the Ionics level, probably longer because of the disk I/O side of things. So you can see a big jump forwards. So enough of me just randomly talking about how the project occurred. What you're interested in is actually seeing the proof of the pudding in the eating. I've got to show you the classic ArtWorks apple because, well, it's the ArtWorks apple. Actually, it's not one apple, it's 2 apples and one of those transparent because at this point it's got to be something of a joke. Well, I've got a display. I was hoping that would actually show it, that it's taking so long for the projector to actually respond to it that you're not actually seeing the speed of it doing it. But I think you can get the idea that it is very, very fast. Another one that people like to see, or at least when it was popular at the London talk, was something called the Celtic Knot 3. This takes I was told about 50 seconds. I'm not quite sure what the hardware was, but The guy who recommended it was, his target was to beat 50 seconds, and if he could beat sort of under 20, it was faster than he'd ever seen. 1, 2. Yeah. It doesn't look that complicated, so I don't quite know why it's such a test, but apparently that is not an easy artwork style to deal with. As you can see, not much of a problem for the ArmX6. Another one that people quite like to see is NetSurf. Although NetSurf has a reputation for being quite fast, it has actually got quite bloated in as time has gone by. If you double-click NetSurf on a lot of machines, you've got a good 3 or 4, 5 seconds before you actually get the window coming up. If we do it on the ArmX6, it's immediate. What I can't show you here, but which again is quite tangible, is the amount of hourglass you get when you finish rendering a website on NetSurf. I timed a Panda board on the BBC News website, and after it had finished rendering the page, it took about 17 seconds before the hourglass stopped caching other things. That actually made it not very usable because you were having to wait for the hourglass to finish. On ArmX6, that time was about 3 seconds. Possibly less, and at that point it's hard to properly measure it. But I mean, basically NetSurf goes from being a little bit sluggish to being, well, one person described it as faster than Internet Explorer on his PC, although that may not be saying too much. Go on, I'll show you the RISC OS Firefox port. It still takes a moment to come up, but you can see even that, if any of you remember trying to run that on Iomixes and things.
I remember trying to run that on a Panda, but on a ArmX, and it's just...
Yeah, and you can see that this is... I don't have internet connection, so you can't see it, but you can see that when I'm clicking things, how it's sort of refreshing, etc. If we go edit preferences, you can see that that's basically usable.
How's that port?
Sorry?
How old is that port?
That is an old port, I'll grant you. We are actually...
wasn't it?
Yeah, it is. That is actually something that we are actually working on at the moment, is Firefox as it happens. But it's proven an interesting challenge because the code doesn't actually compile anymore. So that's proven an interesting challenge. But I don't know, can we throw an HTML file at it? I don't know if I've got anything just lying around. I think you get the general idea that Firefox is... Oh, there you are. Google page presumably pulled out the cache, but you can see that came up in a perfectly acceptable length of time. I was able to log in and use Lloyd's online banking through Firefox without it feeling unpleasant whatsoever. So you can see the machine is sort of cutting through things without really missing a beat. I won't do full screen stuff because the projector doesn't seem to particularly appreciate it, but if we look in the other apps, we've got things like Ovation Pro, our classic Arcom advert. It's slickly fast. Below something like Private Eye, open a JPEG. It's a big JPEG, but it opens it instantly. Somewhere on here I have a very, very large JPEG. This is something like probably between 20 and 30 megapixel digital camera photo. You get some idea of the resolution from the scaling of it. Scale view. drop it down to 25%. You can see that it just handles it. This is my somewhat chaotic desk workbench with the other design of the ArmX6 that we offer, which is this is about the size of an A7000, a bit smaller than a RISC PC, and it can be used horizontal or vertical like a RISC PC. I thought I'd bring that shot along because it shows the other ArmX6 design that we offer, and because you can see how it copes with dealing with sort of the biggest, fattest pictures that come out of your digital camera. Another example of how it translates into real-world performance is Messenger Pro. Here I have my email folder, sort of my work email folder. This is something like 4 gigabytes in size. It might be bigger than that. There are, I believe, 30-something thousand emails in the inbox. So it's a fairly hefty test. Show demos. Messenger loads basically like that, and if we open our 33,000 inbox, bang, we're there, and we can toggle between threading and no threading instantaneously. I can search that for everything from John Balance, for example. Very quickly. I repeat, that's 33,000 emails, roughly, well, multiple gigs of data being dealt with. To put some perspective, that is about between 5 to 10 times faster than what we were seeing on Pandaboard. And is at least on a par, if not slightly faster than my solid-state disk-powered RISC cube. And that is saying something because Virtual Acorn actually benefits directly from the SATA speed of the host PC. So if you've got a solid-state disk in the RISC cube, you basically get PC speed in Virtual Acorn of your disk stuff. Here you see in the ArmX6 at least as fast as a top-of-the-line RISC cube, if not faster, in something that has always traditionally been an absolute Achilles heel problem. I also ran it as, and if you look here, you can see I think it should be set to yeah, it's set to running in network server mode. I had it running as a network server to my Windows machines, and they were, thanks to the gigabit Ethernet, syncing those 30,000 emails in a matter of seconds. It was impressive as a mail server to Windows machines. I was running Windows 8 email client, which is pretty grotty, but I also ran Windows 9, Windows Messenger Pro for Windows and various other email clients onto it, and they synced with it without skipping a beat, and you could just watch the emails. The way they did do it, you could see the sort of numbers of emails detected counting up as they sync, and it just sort of thousand emails just coming in. It was good stuff. So it's very pleasing. As you can see from all the different software applications and things I'm running, we have a range, all the usual suspects of software, all working quite happily. ProCAD there, which I helped out with the development of the RB7 version TechWriter. You've seen me demonstrate these all on previous machines. Effectively, you have 100% software compatibility with what we did previously.
Does that apply to the Pandaboard as well as the Pandaboard?
The only thing
You specifically mentioned the Pandaboard before.
Yeah, sorry, I'm mentioning Panda because that was our previous generation of machine too. Compared to the original Harmony, there was really only one program that caused problems, and that was Photodesk. And we've done work to make sure that Photodesk does run, so if I double click on Photodesk, on Pandaboard it wouldn't even load the icon on. You can see. Where are we? That's sample, not samples. Examples. So you can see, that's quite a less. So yeah, and basically, if it works on, if it works on Beagle Stroke Panda, it will work on ArmX6, which was always the goal. As I say, we didn't want to lose any software, so we haven't lost any software. If anything, we've picked up new software by fixing the bugs. Exactly. So you can see it's a solid system, and I mean that's one of the things. Because we've spent so much time testing this. When I started off, I said, well, on previous machines we had the first year where we were adding features and getting things sorted. With this, we've come out the door with a machine that is far more stable than pretty much any RISC OS machine previously. We're possibly back to the RISC PC era. Certainly, we're unquestionably more stable than any of the Ionics onwards in terms of out-of-the-box reliability, which has been very pleasing. Indeed, the amount of, we've been shipping machines since February, and I think even the end of January. But I've had virtually no feedback beyond, oh, this is great, from people, because the systems just work, which is exactly what we were hoping they'd do. But you know, always when you launch a new machine, you kind of expect to get a few teething problems. The only other things that we've had from people who, when they've gone from sort of RISC PC to the new machine, they're wondering how to do stuff that they did before on the new machine. You know, silly stuff like how do I listen to an audio CD, or will you use music CD? You know, if you go to the sound folder, music CD. You know, you've got to use that rather than your existing CD player. So it's been much more sort of practical questions rather than anything being reported that are problematic. At which point, effectively, we felt that the project has delivered what we set out to. It's a next generation platform. It draws a line under all the previous hardware by being one piece of hardware that is the next generation beyond everything that has gone before, delivering a greater level of stability, fully featured system, solid state discs. You've got an optical CD drive in there. You've got a card reader for reading, well, virtually every format of card reader and then some. You've got a whole heap of USBs. There's 4 on the back. There's a 5th one there, and if we,
How many USB 3?
That's a good question, USB 3. The board does have a blue port on it, but RISC OS has no USB 3 stack, so they are all USB 2 speed. However, they are far faster than any USB ports that we've previously seen on RISC OS, because previously USB has been shared by much of the I/O system. If you actually sort of connect up, use up on USB on Panda more than previous, because the USB is being fed for Ethernet, for storage, for everything else. It's not particularly neat. On this, I've hooked up a USB to IDE adapter to transfer some of the data across onto the machine, and the data actually move across. We know that a few people don't particularly get on with the idea of download services and electronic purchasing, so we thought we'd do a CD with things like Descade and a few, Delegate, our deletion protection system, which is currently available at Clean Store, and a few of our other bits and pieces for the show. I haven't shown Delegate, but if you haven't familiarised yourself with that, it'd be well worth checking out. Do ask me about it. Basically, Delegate provides deletion protection and system protection. So you can't accidentally delete the wrong thing, and if you do delete things, you can easily recover them. If we click the icon bar, you'll see currently I've got nothing deleted. But if I was to delete Big Butt Bunny, say, you can see it goes straight into the bin. We can double click it to actually see to look at what's in the bin, or we can click on it and restore it back to where it came from. And you can see Big Butt Bunny is returned from where it came. The delegate system blends seamlessly with the filer. You can tell it which folders to ignore, which folders to protect. It copes with network drives. It can cope with things like RAM disks and Acorn Access shared drives, as well as Landman 98, and handle each intelligently. It can prevent you accidentally deleting boot sequences or the loader folders, which is important on Beagle Panda and things. And it automatically handles situations like where you delete the same file from several locations. So if you've got several things called exclamation mark run or a run image or something from different locations, it handles those automatically and can then restore them back from whence they came correctly. It has a concept of a job. So if I, for example, were to go into this customer folder and delete a bunch of stuff, it has let me delete boot in this case because it knows it's not the master boot sequence. And you can see that it's put that into a job. If I was then to delete that folder, it becomes a separate job. I can restore the whole job, or I could delete those again. I could just choose that I want to restore bundles through the DTP network, and just those ones come back. Because they're folders, we can also look at the contents by double clicking on it, see what's what, and pull individual things out as well. So everything is restored. If you hold down the shift key when you delete things, everything will bypass the system so that you aren't constantly having things being recycled. You can set expiries so that things get timed out after a certain period of time. You can choose to have no icon on the icon bar so the system is completely transparent. You can choose where bin content gets stored. You can choose remote drives, boot guard system, choose how much of the boot sequence is protected. You can set up ignore, and you can set up to protect specific folders along the lines of boot guard so that you can't accidentally delete your work folder or something on your system. Basically, if you ever have instances of slippery fingers, you need a copy of delegate. It's designed to basically be the definitive deletion type program for RISC OS, and simply draw on all the good stuff that's previously been done with sort of clean bin and recycler and recyclone on adjust, and basically come up with something that is designed for RISC OS 5, integrates seamlessly, and copes with all sort of networking permutations and combinations that can trip up other bin solutions and things. Even things like the Windows recycler has issues once you start having multiple drives and network stuff, and just basically gives up at that point and doesn't bother, whereas Delegate can actually handle all of that as well. So it's designed to, be the best there is. In one sense it's a small, trivial thing, but in another, when you accidentally lose work because you've clicked the wrong thing, and yes, it happens to all of us, you'll be glad you had Delegate installed.
Did that come about as you were developing the board here?
In a sense, yes. I had always been conscious for a long, long time that RISC OS lacked a particularly good deletion protection. The only thing that really I was particularly happy with was Recyclone, which is the adjust bin. And even then, it had its limitations. And of course that was tied into RISC OS adjust, which effectively meant that RISC OS 5 users were left out in the cold. So it's been something that's been on my mind for probably 2 or 3 years. And it was also something that I felt ought to be developed for machines. It hasn't quite come together like that because in the end it turned out to be quite an extensive project. And when I say extensive, you can translate the T for a P. Expensive project. So it ended up as a standalone thing. But I was very conscious that RISC OS did not have a recycle bin that was suitable for use on modern machines. And that meant that, yes, I lost data because I accidentally clicked the wrong icon. I knew other customers who were deleting wrong things and lost data. And particularly when we had things like for the Panda board, we developed something called Boot Guard, which protected chunks of the boot sequence for the purposes of stopping you deleting the loader partition, which could really mess things up. And so it was a sort of extension of Boot Guard technology to go, if you're already trapping deletions of particular things, to develop recycle bin approach really is you trap deletions of specific things and then do things with them. In practice, it didn't turn out to be quite as simple as that, because whilst that in principle does, there are so many things in RISC OS where there aren't hooks where you'd think there would be hooks, that coping with different selections of this, that and the other, and what do you do if you protected a folder here but you want to delete a folder there and it's a subfolder way down the tree and you're deleting something further up the tree? It does create a whole lot of little things that you don't initially think about, and when you do, it ended up getting internally rewritten about 3 times, I think, before it totally. And even then, I did some talk at the London show, and the computer's date was we hadn't finalised the ArmX6 clock system. So the date was 1970, and the system didn't delegate being developed in 2010, and made a somewhat rash assumption that the clock would be 2000 or later. So anything below 2000, it didn't know what to do with. So I merrily clicked on delete in the demonstration. There went my data. Well, it's a copy of fireworks, I think, so it was easy to get it back. But so needless to say, that was fixed fairly rapidly.
On that point, one of the problems with the Beagle board was the lack of a battery. Hence, you put one in the army. There's some discussion recently about that as well. Is there a battery on the clock on this?
Yeah, with ArmX and with this, we use custom hardware for it. On ArmX we used a larger, CR2032 watch battery, like a BIOS battery. This one we actually used a slightly smaller battery in order to make, for physical reasons, we wanted to fit a particular form factor that CR2032 wouldn't do. So we've used a slightly smaller, it's a similar watch battery style cell, but it's the next one down in size from a CR2032.
So it is actually quite easy to replace it.
So all you have to do is buy one of those batteries, which are pence.
So they're not rechargeable?
They're not rechargeable, no. But basically, I'm told, I must admit I haven't tested this because, for obvious reasons, that you should be able to have the power off for a couple of years before the cell is discharged.
I think it's a 3-year life of the battery, at least 3 to 5, depending on.
Okay, well, I've been conservative.
It won't depend on use as well?
Well, that's it, exactly. It will depend on the use.
I mean, if you're saying 3 to 5 years in storage periods,
And storage use-ish. I mean, this is the catch.
I was using 2 years. I was using 2 years of storage.
Yeah, they're just looking at it every so often. It's not like it's been hammered all day.
But
I think it reads it and then saves it. And
just, I've used bits of kit with those CR2032 batteries in which definitely been able to run them down.
Oh, you can.
Reasonably short though.
Yeah.
Not excessively short, but after some years and then put them in storage for a few months, I learned to put new batteries in before we use them.
Yeah, I think
I can say that we haven't had anybody report any battery issues on ArmX. Now that's only been 2.5 years, but as I say, the cell is slightly smaller on ArmX6, but whilst ever it's got mains electricity to it, it's going to be using the mains electrics, not the battery. So I'm fairly comfortable that the batteries are going to be lasting, well, certainly for 3 to 5, and then after that, if you have to replace a pound battery to get the thing, the world. And
It won't leak.
it
It won't leak in an area like a RISC PC.
and it is socketed, so it's totally user replaceable.
Right.
So it's just a case of literally push the old battery out and slap the new one in.
Yeah.
So it's not a problem. So yeah, the problem we had with the original Harmony was that the board was designed to take a battery, but a lot of it was we fitted the cell that could fit there. They actually spec'd it for a slightly larger cell, but you couldn't buy that size of battery. So we had to go with what was available.
Yeah.
And rather frustratingly, the spec for the battery, it's actually, the problem isn't the battery, but so much the charging time it takes to charge. And the problem is that batteries of that size, the spec for how much the current that you feed into them is right on the cusp of the two values that the board can do. So I think it's sort of I think we've got 1 milliamp and 1/100th of an amp or something. Are the two values, or is it 0.1 and I forget the exact numbers, but basically the next option up is just fractionally out of spec for the battery, and literally only fractionally out of spec. So I have actually suggested on a few occasions that people try actually charge it with the fact that, and that does massively increase the speed of charge. I mean, you can see it shoot up in, well, probably 10-fold faster or something. It's, maybe not quite that much, but it's significantly faster to charge. But you run the risk of charging slightly out of spec of the battery, and with batteries you do tend to, trickle charging tends to be the order of the day if you want to get maximum battery life out of a thing. So I'm always a bit conscious of saying, should we be charging them fractionally out of spec for speed, or going with safe and, so. Yeah, at this point in its life, I would probably encourage you towards putting it on past the charge speed if it's a problem. But then, that's a personal decision as to how you want to do the machine ready. So yeah, it's, as you can tell, it's been busy times for our Interactive, and quite an extensive project. It has been a project, as I say, that has, because it's been developed from the ground up in this manner, it has been done on a commercial basis, which is why some of the things are being kept as proprietary components, particularly the SATA driver. There are, some issues. I mean, the way RISC OS is licensed, everything does ultimately have to go back to RUM, or rather to Castle, and by virtue RUM, under how the licensing system works. But the proprietary components have been kept as on the longer term Castle license, simply to allow the people who put money in to see a return on the money, the work done. I don't think it's entirely unfair for folks who spend months of time working on things to be paid for the time spent on things.
So is there a standard spec of machine?
Yeah,
like
sorry, I
standard
haven't talked about that. Basically, I showed you the other case design. This is one case design, this is the other case design. All machines come with 2 gig of RAM, which is basically the maximum that RISC OS can handle, period. All sorts of weird, horrible stuff happens once you go above 2 gig in RISC OS, so you don't want to go any higher than that. Our standard spec is to ship with 120 gigs of solid-state disk on the SATA interface. There was really no point in looking at traditional. People say, why didn't you put an ordinary hard disk in rather than a solid-state disk? There really wasn't any point. Hard disks, for a start, hard disk capacities tend to start at about 500 gig, which again throws up a few issues for RISC OS in terms of handling that sort of capacity. So you'd have to format down. And quite frankly, if you can support solid-state disks, the performance benefits, the power benefits, the no moving parts, silence benefits, you wouldn't pick to put a hard disk in if you given the choice. And so we figured solid state disk all the way. We do a 250 gig solid state disk as an option, if you wish. Every machine ships with a DVD writer. This particular case, we do a card reader with that one. Gigabit Ethernet, HDMI video, USB ports.
Is it just HDMI?
It's just HDMI. I mean, HDMI can go out to HDMI or it can go out to DVI, so basically any digitally equipped monitor will be okay. No VGA because, quite frankly, it's 2015. If your monitor is still VGA only, in all honesty, you owe yourself a new monitor.
What's the top res?
The top res that we offer in the custom MDF is 1920 by 1200 at 60 Hz. However, I know that Adrian runs his at 2000 odd by 1500 or something. So it's some slightly peculiar modes that he has created that basically push the limits of what it is. Now, I was actually reading in the hardware reference manual, which is about 2,000 odd pages long, that the actual HDMI PHY can be configured up to do 4K.
Right.
And it's a HDMI 1.3C spec, which basically means it's got support for a slightly long-winded answer here. HDMI 3B and 3C, 1.3C, added support for 3D images. In order to do 3D at 60 frames a second, what they had to do was you either had previous to that you had to split the screen down the middle and do half resolution. But what they wanted to do was have enough bandwidth to be able to do the two images that form a 3D image in one block at 60 frames a second. So effectively, that's two 1920 by 1080 screens simultaneously. So that immediately to do that, that's you've doubled the amount of screen stuff that you could do. Now, 1920, if you double up a 1080p display in both directions, you effectively get the 4K resolution. But if you're doubling in both directions, you need 4 times the amount of data. So we've already got to 2 times the amount of data with 3D. What they do to squeeze 4K out of this kind of kit is to say, well, if you can't fit twice as much data through it, you halve the rate at which the data goes, and then you can fit. So for 4K spec, standard 4K spec is 30 frames a second. So that's what's spec'd in the hardware file, is a 4K at 30 thing. And any 4K monitor or TV should do 4K 30 because that's the limit of an HDMI connection. That's what you see on all of the 4K monitors that offer HDMI ports, is that they can do that. Now, granted, it would be nice to do 4K at 60, but even in the PC world, that throws up some interesting challenges. You don't have to use DisplayPort and that kind of thing. But that's another area that we are looking at and working. At the moment, we've got up to the. There are various little interesting challenges that have to be worked around for doing that. Not least that you have to run the HD in a different manner in order to open up the extra bandwidth. And according to the data sheet, the mode that we're running in is the most compatible. You can do this at less compatibility, but more bandwidth, or you can do this for maximum compatibility at less bandwidth. So at the moment we're in the less compatible, more bandwidth mode, because we figured that it was probably more important for a wide range of screens and things to be compatible out the box. So in practice we haven't heard of anybody having any trouble with any of 1080p stroke 1920 by 1200 screens. Indeed, we've sort of moved to supplying quite a number of 1920 1200 screens as standard, rather than 1080p going that little bit higher. because we found some nice IPS ones at about 229, something like that, for an IPS 1920-1200. They do command a price premium over the 1080p displays, but if you're working on documents and things where top to bottom tends to be more important than left to right, having that extra bit of thing for 1920 by 1200 rather than 1920 1080 is actually quite nice when you can do it at 60 Hz and have an IPS panel screen to go with it, not an obscene.
Have you covered the really wide screen with 21 to 9?
We haven't in the standard monitor definition file, and it does throw up some issues because the actual width of the screen goes beyond 2,000 pixels. And there are certain limits within RISC OS that are built around the idea of 2,000 by 2048 by 2048 things. It would require changes to do the super wide, and for reasons I've just mentioned about the top to bottom, my personal take is that 21 to 9 monitors.
Very nice.
I would say that I would find that I don't find them so productive.
3 A4 documents.
Yeah, but I want top. I work top to bottom. I don't need. I've already got.
You mentioned that could you just spell out the difference between that case and the flat large case?
Basically, with this case, it goes this way round, and that's that. The flat case can be either used flat on a desk with like an A7000 or something, or on. To be honest with you, it's probably primary mode is actually on its side, like the RISC PC could be used. It comes with a little bracket so that you can have it on its side. The power supply in it is quieter than the power supply in this one. This one isn't obscene, but in a totally silent room you can hear it. In the other one, it is hard to hear it in a quiet room. I'm paranoid about silence. I've probably mentioned this before, but I'm quite happily spending £100 on a new power supply for my PC so that the power supply doesn't make any noise on when the machine is idle. I'm also sort of on a quest to get the maximum performance out of a PC with zero noise out of the thing. So I am a bit of a stickler when it comes to sound. So
are all the ports the same in the back?
Sorry, all the ports and things, it's the same motherboard and things, so you stick same
card
port.
reader on the front, is that?
There's no card reader on the thing, but you can use an external card reader. You've got plenty of USB ports, so that's not an issue. We can fit the quieter power supply to the shoebox design. We do have to charge extra because we have to buy the power supplies extra.
How much space is there?
Both, to be honest with you, both of them have similar amounts of free space. The A7000 one, in principle, is a larger case, but in terms of how much expansion, etc., in it, there's a surprisingly large amount of space inside this, and therefore the actual amount of expansion in both is about the same. But theoretically, if you were prepared to sort of be a bit creative, you could probably fit more in the larger case just on virtue of it being larger. But don't assume that the shoebox is super limited on storage, on expansion space.
I think the question was how much space is there?
What did you want?
Is it half full?
Oh, I see what you mean. Hard to say. What did you say, Alan?
Well, you can squeeze a second SSD into the
Well,
spare case,
You can,
Right.
yeah,
but
into
it's
this one.
very easy to do it in the other case.
Right.
Possibly get a third one created in the third case.
But basically, it's a single drive.
Yeah,
I think is part of the thing. If you're at the DVD drive, it's just going to stay at one DVD.
Oh, I see what you
Yeah,
mean.
yes,
Yeah. I mean, both cases are designed to be compact, because we know that we've had people say, "Why is it so big?" And we've also had people say, "Why is it so small?" So you can't beat everybody. And there's certainly some people saying, "Oh, well, I mean, the ArmX was half that size," and we're saying, "Well, actually, you've got quite a lot more stuff inside this than the ArmX."
Is it as badly accessible as the other Mini? I.e. my fingers won't do the right angle bend close against the side.
If you're wanting to do if you're wanting to DIY and actually go in and do stuff, you'll probably find the larger case, the
So-called LC cases.
is probably the better choice.
It's easy to work with.
When Alan's doing the actual, I don't know how many of you know how we actually work, but Alan likes to do the Meccano.
I do the Meccano. and it is the clever stuff.
Yeah.
So Alan has a preference for not this case, the other one.
It's sometimes the LC cases.
Yeah.
But in terms of, 6 of one and half of them the other really. And as I say, it's surprising how much stuff you can squeeze into this one. Yeah. So there's somebody.
Andrew, in terms of your commercial sponsor,
Yep.
has he actually started taking delivery of the machines yet?
Oh yes, he's got 20 something of them live running right now.
When I was there.
Yeah, in fact we've got several commercial customers running on them. There's
Which form did he take? The shooting?
well, a lot of them are just literally running on motherboards.
Right.
In racks, because when you've got 20 machines you don't have 20. But we do have some of the commercial customers have gone with this design. I think to be honest with you, I think we've got some on this one and some on the going for both of them, to be honest with you. But the big deployment, or the single biggest deployment, which is one company running 20 something of them, is effectively all rack mounted, because they just have lots of servers in a basement basically. That runs, I think, about a third of the Dutch medical system runs on ArmX6 RISC OS boards now. All this, you know how the British government can't do integrated patient records between hospitals with medical GPs and things? Well, the Dutch system does it with RISC OS. They don't know it's RISC OS, but
I think we used to run that off the television system on RISC OS.
it's
cable news and stuff.
so that's being used. There are other commercial customers using it for email and databasing. Another one is running a series of. It's a company that owns a series of racing circuits. Not sort of Formula 1 racing circuits, but sort of stock car and dirt bike and type racing circuits. And they run, again, it's big database systems of drivers and races and times and everything. They check things get checked in and checked out and make sure that everything is running the same systems out, put the tickets and this, that and the other for the races. That basically all runs on database system that runs.
What are delivery times at the moment?
See that man?
We're back to about the wazoo, as you probably gathered. That we started taking pre-orders back in October, and that rather exceeded our modest expectations, shall we say. If you were to put an order in today, you're probably looking at 6 weeks, I would say. But I am likely to sort of juggle, with people's permission, I'm likely to juggle things around so that because you've got the Wakefield show coming up, it would be in my interest, shall we say, to deliver as much as possible at the Wakefield show to people who are Wakefield members. The way we've been doing it is that I quoted a price of $699, the same price as an ArmX6 699, back at the London show, and I've stuck to that price, although the prices to us have actually risen slightly during the period. I've stuck to the same price, and what I've said is that once we can actually deliver from stock, the price will actually rise. But whilst ever it's a pre-order and I can't deliver a machine right away, then the price stays at $699, and we'll honour that. But we are asking for a £150 deposit to secure a position in the queue. And be honest, it helps with cash flow and dealing with quite expensive machines through the system.
Are there any other options apart from the different solid-state drives?
Not really. I mean, the board can take a series of micro SD cards as well, so we can offer additional drives in the form of additional micro SD storage. Obviously, that's not as fast as SSD storage, but for backup purposes and things like that, It has a useful way of having additional drives that are neatly just stuck inside the machine, and hey, if you've got the functionality, you might as well use it. So I have supplied with between 64 and 128 micro SDs alongside the main drives. We can fit additional SSDs and things like that if people want to go that route. Other than that, there isn't a great deal of way of options, simply because most of the things in the board are already to the max. You know, we can't offer you different RAM specifications because 2 gig is 2 gig is 2 gig, as far as RISC OS is concerned. That's your lot. So yeah.
What software are you bundling with it?
It's pretty much the same as what's gone before, but it's just with sort of revised and updated versions of things. So you've got things like the video playback stuff as standard, which was more limited on previous generations of machines. Effectively, it's what you see here, except for the stuff that's in show demo, which is third-party applications for testing. So if you're keen, by all means, have a little look. Customer is also not included. That was a customer's data that we were backing up from when I was doing a repair job the other week. And X is development files, but the rest is the standard disk image.
Have you done anything with USB audio? I know there's been a sort of thread running around on real USB audio for pandas.
I have a sneaky suspicion that is built into the machine, but I personally haven't tested that.
Right. Yeah. Okay.
And because it's a two-way street with rule.
Yeah.
As and when changes go into the rule tree, they go into our tree.
Mm-hmm.
So any work that's been done on that goes in.
Should. Yeah.
So the only reason I'm putting a caveat is that I'm not sure how much is fine. I know a lot of work has been done.
Mm-hmm.
I don't know how much of it has actually trickled up the tree into the release stuff.
I think there were bespoke programs originally written on ArmX. So
yeah, I'm not. I had a feeling that a lot of it had finally migrated back,
right.
But I might be wrong on that.
No.
I mean, anything that's been done will work on this because there's standards. The way that all of this works is that you have a HAL, which is where all the hardware-specific stuff is done, and then you have the USB modules and stuff, which then talk to the HAL. The HAL gives it various entry points, and the USB goes up through that. So as long as the HAL has everything turned on, which it does, then the USB modules just plug into that.
No, it's just to seem to remember you saying, I think previously on ArmX we were doing something with audio. I can't remember what it was, but
well, I say all of that's implemented here because it's all a superset of what's gone before. I mean, it is distinctly a case of each building block is a one step along the road. And in a sense, this was the first opportunity that we've had to actually go that step beyond and actually develop the whole thing, but we couldn't do. In an ideal world, you'd have done this. This would have been possible back when the Ionics fizzled out, as it were. But you can't do that. You first have to have all the work that's done to get Cortex. ARMv7, and then you have to have the improvements to the USB, and you have to have the improvements to this, and it's a moving thing, and you can't sort of focus on SATA until you've got all of that architecture stabilised and working. And as we saw, even that when we thought it was stabilised and working, it wasn't. So, but we couldn't. The time that it takes to fix those bugs is only possible because of the work that's been done to get us to that place. There. But as I say, what we try to do with this project is to deliver a project that is that new baseline. I keep using the word baseline because for a long time the Ionics has still been people's baseline machine, even though we've had Harmony and ArmX. Still the question is, what do I replace my Ionics with? Because they say, well, we say, oh, we'll replace it with an Harmony X, but they say, well, look, my 10 gigabit Ethernet on my Ionics, or I've got fast disk speed.
Yeah.
Will the ArmX be? Well, yeah, but it'll be fast in most areas, but it might only just match it. And people frown at that. This is that. And the bottom line is that it's giving the level of, this is going to sound slightly negative, but I don't mean it to be. It's giving at least the low performance level that we're getting out of the virtual RISC PCs on RISC cubes, but in native hardware across the board.
Yeah.
Which previously were, things like the disk and stuff, we weren't getting that. And this is in a sense the first machine where everything outperforms the virtual. I think that's a very good place to be.
I'm going to say on that point, do you think you actually, in terms of actually making RISC OS fit the purpose of the new generation hardware, have you given it a longer life on the hardware, or have you reached the limit? Because at the time you seem to indicate you've reached the limit with RISC OS.
Certainly RISC OS does have limits, and I mean, one of the big areas of development at the moment going forwards is going to be trying to remove the existing limits on what we do for the future. In a sense, ArmX6 is at the limit of what RISC OS will do in a number of areas. And we need to be looking at addressing things like the size of disks that we can deal with, for example. At 250 gig, effectively that is the maximum size due to the way file core and things work. We thought we could get away with 512 devices, but one extra bit is used for another purpose that we thought was free, isn't, so it was back down to 250 as the limit. 2 gig, as I say, in the RAM. Some of these are quite difficult to deal with, but on the other hand, 2 gig of RAM on RISC OS is a stupidly large amount anyway. So some of the, whether that's actually necessarily something that you actually want to solve. I mean, you can always run, say, a 4 gig machine with only 2 gig turned on, as it were. So whether those are massive priorities to sort on RISC OS, but certainly there are limitations in RISC OS which are unfortunate. But on the other hand, we also have to look at what people want to do with RISC OS, and I think what we've got meets people's current requirements pretty well. And I think the next thing we have to do is actually look at getting some software to take advantage of. That's, I said that one of the things that John has been looking at recently is things like the Firefox port. I don't want to get people's hopes up or anything on that score. I mean, he just wants to make sure that it compiles properly and works. And the tools are actually working to compile things, because things have been neglected. Not through any fault of, say, ours or most folks, but just things, time passes, things aren't as maintained as well as they perhaps should be. And so we're trying to sort of get some of the backroom infrastructure rebuilt, because I've said this with the ArmX, so forgive myself, but what we're trying to do with the computers that we build is build a community as well as a computer. It's not just a case of let's throw out a computer at the cheapest possible price and say, well, hey, job done. There's no point doing that, because it doesn't help RISC OS particularly. And so what we try and do is actually build something that's bigger than just a machine, involves the people and also the infrastructure behind it, so that the tools and everything else gets developed alongside with the machine. And that's what's happening off the back of this. And so I mean, that was what John phoned me before I set off, to say that he'd just managed to get Firefox to compile again for the first time in probably 10 years. As I say, don't read too much into that, because it's more of a case, it's a bee in his bonnet that he saw it and it didn't compile and he thought jolly well ought to. But that I think has to be the next thing, is improving the software infrastructure. There are things like a lot of ported software uses something called shared Unix lib, and there's a version of that with hardware floating point enabled in it. It has been since the ARM Mini came out, more or less, and they still haven't done a formal release of it. So we're trying to apply pressure to ensure things like that actually finally get out onto the market, because in the nicest possible way, we've had hardware that can do this for 4 years now. It should be, every program should really be out there trying to take advantage of this kind of technology, because otherwise we're not exploiting what we've got there. And so that's going to be the next priority, is sort of how do we leverage more of the hardware and technology that we've got in the box. I mentioned about video acceleration. That's another area that we're looking into, because we've got this capable hardware, and one of the reasons that I sort of say it's a new baseline is because the more people we have treating it as a baseline, the more we can pull out of what we've got. If we don't have to support, I don't mean to poo-poo the original Pi, but being ARM v5 device with limited VFP and other technologies, and you were effectively, it's another Ionics. We don't really need that from a RISC OS perspective, because it means people will try and make the code compatible back to that point, which means that they won't take advantage of what the hardware is available. And yeah, it's wonderful if a program can be made to work back onto that, but you really need a point where we say, yeah, it's not okay anymore to try and make every last piece of software work on an ARM7 RISC OS 3.5 machine. It's not helpful. Take advantage of the modern hardware, make the kit, use what we've got available, and actually, it opens the world for more advanced software to be done. I mean, that was one of the things again with the Firefox, we found that it was still targeting a strong ARM processor. It barely even worked on a strong ARM processor. So I mean, let's target something modern and Cortex A9 type architecture, like the ARM v7 CPU instructions. I mean, at least the Pi 2 is an ARM v7 device, so we can more or less at this point say, right, from going forward, everything is going to be ARM v7. And I appreciate that if you've got a RISC PC or an Ionics and you thought you're looking at me and saying, I wish you could still support that. Yeah, we're still going to try and make sure that things do, broadly speak. But I mean, we need to cut some of these ties to the past in order to move forward. And here we've got hardware that is more than capable of it. We're looking at ways to use the quad-core processor that's in there. There are interesting ideas of running additional copies of RISC OS on the other cores so that things can be handed over. Or, for example, for our commercial customers, we offer remote control type operations. We've actually, for the first time, RISC OS has got. Somebody said how stupid it is to run servers on RISC OS. Little do they know, but I mean, we've developed hardware monitoring and debugging. If the system locks up for a long period of time, it can be told to auto restart. So you can actually if you're running a server type instance, if the system crashes, it can automatically restart and reboot and return to where it needs to be without anybody needing to actually go and poke it. We can do remote operation and remote ROM upgrades and remote to our business customers. With a multi-core processor, we can run another copy of sort of minimal copy of RISC OS on one of the cores to offer a sort of remote control systems. So there are interesting options that will become available by utilising the hardware that we've got, and that is really our next thing. I talked about the long-term availability and how important that was. The ArmX6 processor, and don't worry, I am wrapping up now. The ArmX6 processor was originally designed for use in automotive industry. Now they expect a minimum 10-year commitment to a part. The ArmX6 I expect for 12 years. That's a long-term viability for a product, and that's what I mean by baseline. It's the line in the sand and something that we can actually build from. Yes, there will be other devices in future, and I'm sure if you read your archive, you'll see things like Cortex A15, etc. But what we've delivered here is a complete system available right now that does all of this with no compromises. There's no USB Ethernet, which you can get on the Cortex A15 designs that are currently available. You don't have software compatibility issues. and you have all the high performance goodness in a format that is working, reliable, robust and ready right now. And that's what, I mean, that was always the charm of the ArmX part. It was a solid, high performance solution that ticked all the boxes, and that's what we delivered. Thank you. Oh, Malcolm.
Have you got the boot? Does it boot directly?
Oh,
Does it boot
yes, I must. Oh, yes, boot. Yes, must show the boot.
The projector will fail. You watch.
Yeah, the projector will fail, but I will turn around the monitor and hopefully you'll be all able to see this. If all goes to plan, you'll know that the ArmX expander board takes a good minute to power on. You're going to be looking under 10 seconds. So keep having a look for the.
Yeah.
All right.
Yeah, there are enough.
All being well.
Yeah, all being well, yes.
Effectively, we're faster than a RISC PC, which I think was the previous champion, as it were, in terms of cold power on speeds. You have to wait for the monitor to wake up. So you can see the module list has already been done. This alone takes about 45 seconds on the Panda board. It's doing the RAM and clear at that point and detecting the solid state disk, and it should now be in the desktop. So you're actually waiting for monitor to refresh longer than it. You didn't see the main you didn't actually see the pre-desk because the monitor couldn't sync fast enough to show it. But you can see that was pretty darn fast. It does depend on what screen and everything else you use, and how fast the solid state disk chooses to respond to that from cold power.
And you'd also presume you have to wait for your network to respond.
If you're on DHCP, you'd have to do wet work respond, or if you're using static RP, you wouldn't have to wait for that. Depends what. Depends what.
Final question. Would there be possibilities at some point of Wi-Fi on GPRS?
We have actually got.
Just to allow a bit of mobility.
We have actually got. There's two answers to that. We have actually got a Wi-Fi chip on the motherboard. It actually connects through. The ArmX6 has 3 SD channels, 2 of which go to SD card outputs. The third SD output is wired up to an SD-based GPIO controller chip. Not GPIO, SD-based Wi-Fi chip, which is quite common due to because ARM devices are used in tablets and mobile phones and things. SD Wi-Fi is actually a very common route in. So that's actually on there as standard. It isn't enabled on RISC OS because there are 2 technical hurdles to do, and quite frankly, being brutally honest, I wasn't prepared to pay the thousands of pounds that we needed to do the work, because I didn't feel it was worthwhile. Basically, the SDFS SDIO driver needs to be updated to support SD expansion boards like that. I believe a lot of that is actually based on what we did pay for SDFS upgrades. So the time we employed Ben to do the full-time dev on the SD side of stuff, I think he had to do a lot of that because of the way that SD auto detects stuff. It has to auto detect SDIO hardware expansions and know how to address them so that it cannot address them, if you see what I mean, in order to correctly deal with SD slots as opposed to the thing. It has to bring up everything. So all of that's in, but some more work I think would probably be needed there, and then we would actually need a Wi-Fi stack stroke user interface on top. A lot of it's the user interface stuff that isn't present, actually displaying available Wi-Fi networks and things will need to be done. However, the reason I wasn't prepared to pay thousands of pounds to have it developed, and you're probably talking about 10 grand, but to put a ballpark figure, it might be a bit more than that, but let's start there, was that we can plug in we have for 25 quid, I think it is, a USB come Ethernet. It plugs into the Ethernet port and powers itself by a USB. And basically it's effectively a Wi-Fi dongle. And you plug in via Ethernet, power it by USB, or via an external power if you haven't got enough power. And that acts as a bridge between Wi-Fi and Ethernet. And that gives you the ability to use a Wi-Fi network. And yeah, it's ugly and a bit of a hack, and we'd all like to have proper Wi-Fi. But it's a choice between a £25 add-on and £10,000. I think that £10,000 was better spent on things like the SATA than it was on the Wi-Fi, because the cut couldn't be done any other way. I think it has to come because it is one of those things that RISC OS needs, but it probably needs to be off the back of some other commercial product, I think. Unfortunately, the current commercial clients needed Ethernet, not Wi-Fi Ethernet, so we need to find somebody for another thing. Right.
I was going to say what my question actually was. Does it boot off? Does it boot directly onto SSD, onto SATA, or does it boot onto SD and then onto?
The latter is.
I mean, at the low level,
yeah.
You know, is the
RISC OS is on an SD card because that's the ArmX6 chip is routed to SD to boot. If you think about how these things actually operate, you need a fairly low-level device with RISC OS on before you initiate a high-level device like a SATA interface, because you don't necessarily know you've got a SATA device on until you probe the SATA controller to find out if you've got a SATA controller. It's a chicken and egg. So you need a low-level device containing RISC OS. Now that could be some flash ROM on the board or something. In this case, we choose to use a removable flash card because it's more flexible than anything else. So that's what we use. So the actual first 2 seconds or 1 second of, probably 1 second of power on is actually loading and executing the RISC OS ROM there. It's actually, we don't use a loader partition in the loading mechanism that you see on Panda board and ArmX. But no, Beagle and Panda and Pi for that matter. We're actually our loader is actually a native ArmX6 loader. So the ArmX6 chip sees it directly and goes straight to RISC OS. It doesn't need to go through.
that's
One of the reasons why the Panda solutions and things take so long is because they go through different stages of initialization. We've developed a ground-up solution for ArmX6, which means that's why you see such a fast boot up. That coupled with your first thing is you load your ROM. You load your ROM, then you initialize all your modules, and then you hand up, and that's when the SATA detects all its devices, and then you hand off to the SATA for everything else. So I mean, you're actually booting in from a clean boot perspective off your SATA device, but the actual ROM is housed separately.
So is that on a SD card that you can take out? I have a habit of wanting to mess around with things a lot, so it'd be handy if I could take a backup of it before I destroy it.
It's not easy to take a backup copy directly because, I mean, you probably could with something like Clone Disk, I would have thought.
Yeah, I'll probably use DD on the next.
Yeah, it would probably be okay. Because essentially what we're using is mapped out sectors of the disk, so that effectively you can't see that it's kept locked, so you can't accidentally delete anything, or the only way to kill it is to render it to reformat from scratch. Because we unfortunately had too many people managing to screw up our things by doing the wrong thing to the wrong files, so we learned our lesson and that works that way. So yeah, if you cloned it with DD or with Clone Disk or something like that, you would be okay. But you can't just copy files off it. It is fully accessible on RISC OS. What we actually do is present a recovery image. So if you see on the icon right here, you have an SD icon. This one actually has a boot on it. Wouldn't normally have a boot on it, but I actually used it as a main boot drive when I was without an SSD for a period. Basically, you have a recovery folder which has got all the things you need to do a system recovery if you were to need to replace the solid state disk, etc. So if you're in a ground zero situation, you've got full disk image, you've got tools like HFlow, seamless settings, all the recovery stuff that you need is present on that SD device. And then you can always rebuild from there in case of an absolute disaster.
The last question,
Yeah.
if this, because you said that you could have 2 or possibly 3 SSD cards,
Yeah.
the question would obviously be, if you've got 2, could you have RAID?
You can't do RAID with those, no, but you could with, there are, for SATA, there's things called port multipliers. And one of the commonly available port multipliers is a J-micron device which is used in a number of NAS devices and actually provides hardware RAID without requiring software interface front end. So basically you have a board which effectively you feed one SATA cable in and up to 4 SATA cables out, as it were, to SATA devices, and then it has dip switches and things on it for actually configuring which RAID mode it's in, and LEDs to indicate device status, etc. And then you can have multiple disks all connected to that, doing hardware RAID.
That would more than fill that case.
That would more than fill the case. I mean, theoretically, the port multiplier, the SATA on ArmX6, unlike SATA on some other platforms, Intel, can actually be used as multiple devices on one SATA channel. So port multipliers ultimately, we haven't actually got all of that working yet, but theoretically, and we tested it under a Linux environment and concluded it will work. ArmX6 can actually have multiple devices, multiple SATA devices connected through, so that you can actually have more than one device on a particular channel. So port multipliers would be actually more useful than just for RAID and things in due course. But
Watch the space.
so what you have to do is make a call where the machine is fully functional for all of the features that we've advertised. And that was what we hit in February, that we had a solid machine with no things. But of course there are always more ideas and more cool things that we could implement and we would like to implement. But if you don't start releasing it and start actually seeing a return on the investment, there is a point where you just have to say what we've got is what we want to deliver, and then going forwards there's always more upgrades. Just like we've done for the existing machines that even have updates. When 522 comes out, there'll be a whole load of updates for the different machines, back to Harmony, etc. So
I suppose you could use 2 SSD disks and then sync disk or something like that.
you could as well be another approach. Okay, well, leave it there. Thank you all for listening.
Thank you.
Rock, helping you with Acorn and RISC OS computing.